How do you determine RAM latency? This is where CAS comes in. To understand how fast your RAM actually is, you must look at its memory timing. It will be listed alongside the RAM with numbers presented in this format, 15-16-16-35. The first column represents CAS latency, also known as column access strobe. This is the number of clock cycles that pass between when an instruction is given and when the information is made available. If you tell someone to duck, CAS latency would be the delay between when you command them to duck and when the other person reacts. But CAS does not exist in a vacuum and must be put into a formula alongside other specifications in order to determine the true latency of your RAM. To calculate the true latency of your RAM in nanoseconds, use the following formula. Parentheses, CAS latency over RAM clock speed, close parentheses, times 2000 equals latency in nanoseconds. If you have a CAS of 15 and a clock speed of 2400 MHz, this would be your true latency. Parentheses, 15 over 2400, close parentheses, times 2000 equals 12.5 nanoseconds. If you have a CAS of 17 and a clock speed of 2666 MHz, this would be your true latency. Parentheses, 17 over 2666, close parentheses, times 2000 equals 12.75 nanoseconds. Thus, higher CAS timings can result in a higher latency even with higher clock speeds. However, just because the DDR4 2400 RAM has a lower true latency than the DDR4 2666 RAM, that does not necessarily mean it is overall faster than the DDR4 2666 RAM. The higher speed of RAM currently always trumps lower latency. This is why the comparison of CAS latency between RAM of identical clock speeds is where CAS matters most. A stick of DDR4 3600 RAM with a CAS of 15 has a true latency of 8.33 nanoseconds, while a same-size stick with a CAS of 19 has a latency of 10.56 nanoseconds. In this case, the DDR4 3600 RAM with a CAS of 15 is objectively better than the DDR4 3600 RAM with a CAS of 19.